Hi everyone, so this is my Norcold TEK-II refrigerator freezer. It runs on either 12 volt or household current. Right now I have it hooked up to the car battery for testing, and it is again working. And I did not expect to get to this point, so I didn't video anything up to this point. But I can still go through and explain how we got here and what went wrong and what I did to fix it. So the story goes that it worked absolutely fine, and it's pretty old. I mean, this is probably 20 years old. I opened the storage bag of the RV because this sits in the basement storage of the RV, and I smelled tons and tons of smoke, and it was just absolutely dead. All the food was ruined, and that was it. So we'll talk about the kind of the disassembly process and what I found. So to start, we'll talk about some of the anatomy of this guy. In here is the cooling box, and it has a kind of an evaporator core all around it, and then in here is all the mechanism. So this is held on by 4 screws. Let's pull those all out. Once you get it out, it's plugged in right here, and it has a little push tab on it. And once that's off, you can set it aside. Some people have issues with this thermostat assembly. That's fine on mine. So the issues I had were in this power supply unit, so we'll dig into that, and I can show you kind of what the deal was. Alright, so basically when you get this open, it'll look more like this than how mine does. So it'll look this board on the top and that board in the bottom. Let me pull that one. So, and how this looks is this 12 volt line will be plugged in over here, and then the household current line will be plugged in over here. And so what you have here is this board is an AC power supply, so it converts 120 volts to 12 volts. So the same as the car battery voltage. And when you want to remove these, you have to basically clip off these feet from the bottom ones because you can't get to them, and then you have to unscrew the heat sinks from the backside. You'll get the board out, and in this case, you know, the components, some of the components have actually full on exploded to the point that I can't tell what they were. So yeah, I'm not sure really how to fix this one. I mean, I don't have schematics or anything like that. So, you know, if you need this AC board, you're, you know, a bit up shit creek. But the good thing here is that this is just 120 volts to 12 volts. And the only thing special about this is this mechanism over here. And basically what this does is if you have household current and this board's running, this relay will switch the 12 volts that come to the fridge main board to that household current. If you don't, it will default to using the 12 volt. And I am using this in an RV, so I really don't need this board for anything. I always have the RV plugged in, and you know, I always have 12 volts available. So I decided to just kind of ignore this board and let it go. And conveniently, the 12 volt board wiring that comes from that board is actually the same. So you can just directly hook up the 12 volts to this one. However, this one was also blown up. So, and I will go into kind of how and why that is. So the first thing we have to do is take this apart. And what you have to do is you have to squeeze these little, nipples to get these out, and you have to unscrew the heatsink on the back. Now, as you handle this board, you want to watch out for these giant capacitors because they can hold a charge and they bite. Let's see if this one has any. No. See, I think this one has... These boards are actually very well engineered. I see a lot of protection circuitry and everything else, so I'm not surprised it's lasted 20 years. So this one was also blown up. And I'll kind of show you what I found, what I ordered, and how lucky I got. So the way a power supply like this, especially one this long, is going to work is you're going to have kind of an input over here, and it's going to go all the way through an output. Now this board also has control circuitry for the fridge, so it has switching on and off for the thermostat, and it also has an inverter. So the inverter takes this 12-volt car battery input and it boosts it to about 20 to 24 volts AC. So it's a the sine wave instead of the straight DC current. So it's a somewhat complicated thing to do. So that's a lot of this circuitry, and then this is probably like the microcontroller, kind of the brain box. And the thing is, in some situations you're going to get lucky and it's going to be a real easy repair like this, and in other situations it's not going to be so easy. So the very first thing I found was that I looked over here and these two were blown up, and you can still see the old black charring on the board, and the actual components had cracks and holes in them. So this one still looks okay, but it has some burning on that side. This one, you can see that it's kind of bubbled, and it looks like it exploded out this side here. So that's that's visibly damaged. And if you look, and these are right beside each other, and these do shared duty, which means basically they're all like kind of wired up together. So this is these are called MOSFETs. And what these are is basically just switches. They're a solid state switch. And I am not sure what these are used for. I think they may be used to actually turn on and off the main power to the compressor. So, I think you have your thermostat and it sends a signal here, and the signal goes to here and it says, okay, send power through to the rest of the compressor. But I'm not sure. But it really doesn't matter. Like, you don't have to understand everything about how it works to figure out what's wrong, right? So you found the component that's burned up, and you need that. So I ordered those. And the thing is, though, you don't often get lucky enough that you just need to replace something that's burnt. Usually something else that's not burnt caused the burnt component. And in this case, I got really lucky to find it. And the reason is because I ordered... Okay, so the burned up components, they were called K2232s. So I got on Mouser and I searched in K2232, or not even Mouser, just on Google. And I found the data sheet for this. And I also found a cross-reference from Mouser.com. And the way this works is, these components are all super old and they've all been superseded, and actually the stats on the newer components are much better. So anyway, I ended up buying two different things that match the specs. The first is the one I have installed here, which is, the name of the component doesn't even matter. But I also got this one. And if you look at them, you'll notice a little difference, right? So this one has this metal mounting plate, and the other one is fully enclosed in plastic. And as it turns out, that's significant, because what this is that this is directly tied to this drain leg. And what this ended up being is a direct short circuit. So I sucked these two out, I put these two in, and I didn't really check anything else, and I should have. I was kind of just blind engineering here. And I went to go hook it up, and to test it, you don't want to just go full force in case something's wrong. So what I did was I hooked up the ground to the battery, and I kind of brushed, the positive line against the positive terminal. And I mean, I was getting huge sparks, and I was like, okay, something's not right here. So I took a meter across the terminals and found a dead short. And so I was like, oh, well, man, that must be what blown it up. And, not thinking about the fact that it wasn't shorted before I put these in, right? That's the dead giveaway, but I wasn't thinking of that at the time. So I started pulling components. The first, I looked over at the power bus here. So this is it's nice that it's a single-sided board, so it's easy to trace. This is the ground, and it goes all in through here. And this is the plus right here, and it goes in through here. And if you watch, it kind of jumps through some things. So you have this this diode here. So I sucked the diode out and checked that, because diodes prevent current from flowing in one direction only. And the diode failure mode is a short, so it'll allow current to flow both ways. So a shorted diode will cause a short circuit. So, but to test them, you kind of have to pull them out of the circuit to get a proper reading. So you have to take a soldering iron, suck one leg out, and test it. And my meter has a really nice mode. If you put it here, and then you click it until you see the diode symbol. This tests the forward voltage of a diode. And what that is when current goes across a diode, some voltage is lost, right? So when you measure a good diode, it should be something like 0.5 volts to like 1.5 volts one way and nothing the other way. And that was good for this. And so I started sucking out, as I thought, these are just coils, so if they're conducting, they should be fine. So I sucked out these capacitors and measured the capacitance, because oftentimes in power supplies what fails are these capacitors. They dry out, and they'll explode and puff out. But like I said, this is a well-engineered power supply. They used really high-quality capacitors, really high-quality components, so the capacitors are still good. I mean, I didn't check the ESR. There's something called ESR, which is the real measure of whether or not they're good. But I mean, I just checked basic capacitance, and they were still good. So I kept going through and through and through here, sucking things out. And I sucked these out, and I sucked this out, and I sucked that out. And this is just a voltage regulator. So what this does is it has 3 pins, and you feed like 14 volts and ground to the first 2 pins, and then the third pin is a regulated 12-volt output. So that's basically going to be used to power like the 2 fans. There's 2 little muffin fans. So that tested out okay. And I got this thing out, and this is this component, and this is actually what failed. So what this is it's called a Schottky diode. And what this does is it allows current to flow from either this pin or this pin, these 2 outer pins, to the center pin. And when I went to test it, I found this. Alright, so hopefully you can see this. The flashlight was giving a lot of glare, so we can't use that. So as I said, these are supposed to allow voltage to flow from the outer to the center. So we'll put one on the center, one on the outer. And you'll see that's 0.138 volts. So that means this diode has a forward voltage drop of 0.13 volts, which is it's a characteristic of Schottky diodes. Schottky diodes are supposed to have a very low voltage drop, and the consequence of that is that they're easy to it's easy for them to short out and break, basically. If the temperature goes too high, they basically just short out. That's their failure mode. And so we look at this side, you'll see it's just 0. You might think, and you think, oh, that's good. There's no voltage drop, but there has to be something, because if there's not, then it's just a short circuit. So let's reverse. Let's put this on you, or let's put this on the outside pin. So this is the backwards. This is the side it's the current is supposed to prevent flowing. So you see this side, it's a dead short both ways. So no matter which way is shorted, and you know, on this side you see it blocks it. So the deal here is that this diode, it prevents it sits here, and it's between the high voltage side and the low voltage side. So when it failed, it allowed a bunch of higher voltage to get into this area, and it blew up these two components. So I ended up putting all those other components back in. I put in a new one of these Schottky diodes, and the correct MOSFET, and lo and behold, it's fixed. So I thought this video could be useful to kind of go into one possible failure mode, and I figure oftentimes when these things fail, they all tend to fail for the same reason across multiple owners, you know. So who knows, maybe you have the exact same issue. So the Schottky diode I ended up using was a VF30100SG, and the MOSFET I ended up using was a N90N. Oh, I'm sorry, I'm trying to read it backwards. I think it's a 032N06N, and that's that. So that's it. Once I replace those components, the fridge works fine on 12-volt mode. Like I said, I can just plug the thing directly in, and this is the same for several marine models, which I'll put in the description. Alright, so this is how you go about finding the actual components you need. So the one component said K2232 on it. And if you look here, you can kind of see that the part number is actually 2SK2232. So you see that over and over again. So 2SK2232. And so you see Mouser has a lot of the specs. So the part, so that's the data sheet. Let's see if I have it. So, and it's not surprising that they don't have it, because it's an old part, it's obsoleted. So usually you have to find an equivalent. So in the case of like a MOSFET here, the data sheet will be available, right? So you got to take this data sheet info and set it aside. Then you go to Mouser or DigiKey, and so you see over here that it's a, you know, it's a MOSFET. So it's a field effect transistor, which is a FET MOSFET, you know, MOS type. So you kind of have to learn a little bit. You have to start hunting and understanding what the component is that broke, you know. So we know through our searching that this is called a MOSFET. When you go in here and you look at MOSFET, there's a bunch of parameters, and some matter more than others. So we can say like it's an N channel, and these ratings, you know, it shows them as being absolute max ratings. But if you search for what each of these mean, you can kind of find out what's important and what's not. So, you know, like drain source voltage is 60 volts. So that would probably mean that if you go above that voltage, you're going to have problems. So you could say 60 volts. All right, so we have 1,700 items left, so we're not even close yet. Um, Gate source voltage is plus or minus 20 volts, so we could pick that. 1,400 left. We know we want through hole because it has these pins. Just 233 left. We're getting somewhere. But it doesn't say it on the data sheet. But this is a TO220 package. I don't really know how you would figure that out without asking. I guess you could find some kind of forum or something and ask what the package is. So yeah, I guess there's some some education to do if you want to try to wing it on this. But we know it's TO220, so there's 3 options here. There's 150 remaining, and 1 channel, which we already have. What's this? Gate source threshold voltage. Gate threshold voltage. 0.8 to 2. So we could do like all of these. $54 left. Basically, if you enter some of these major parameters, you're gonna be fine. And then, so like here's something, the part looks familiar. You know, I see here, like here's 34W. So power dissipation. So I see this one's 35 watts. So that's another parameter we could specify. And this is the drain current. So the current that's going through drain current DC 25 amps. So it's got to be at least 25 amps. So they only have 30 and above. So what else? Power dissipation. So we know we need 35 watts or more. So that's most of the parameters specified. So the trick here is that oftentimes when I buy parts, you know, these parts are $1. You know what I mean? So I will buy multiples of each. I will buy usually, so if I need 1, I'll buy 2. And if I need 1 type of part, I will buy more than 1 type of part. The mistake I made, so like, you know, this one right here, 60 volts, 106 amps. So, you know, it's got to handle only 35 watts, but this one handles 87 watts. So this is quite a bit stronger of a MOSFET. And I think that's probably better technology, that they're higher spec parts. I'm not really sure if that's the case, but basically as long as you understand these parameters and you get something that can handle more, typically that's okay. And it's not okay in some cases with things like a capacitor. Sometimes the capacitor's value is important. So even though you'd say, oh, a larger capacitor is fine, if it's trying to smooth some kind of ripple or something like that, the value could actually matter. But if you look here at the pictures, there's 2 different kinds here. There's the metal backed, and there's this plastic. And I didn't realize this. So this is called a TO220, and the plastic one is called a TO220 FP, and that means full package or full plastic, something like that. And basically this one is fully plastic, so it's galvanically isolated from that heatsink. You remember we mounted it to. as it turns out, this middle pin is connected to this gate, so that is the source of my shorted pin. so, so luckily, I bought one of the parts I bought was in this plastic packaging, so I was okay. And the same thing goes for the diode, you know. So that part number was this. So you'll come here and you'll see, like, this is the part. It's non-stock. Call for a quote, and you come in here and you say show similar. So, you come in here and you say, what are my important components? Well, you want the plastic packaging TO220. You want the forward current, so it should be able to handle enough current. And what if we do 60 volts? So there's one replacement that is exact. And I don't know if I used exactly this. Oftentimes you can deselect, and there may be a lot more parts that are actually higher end parts that can handle higher voltage or higher current. But this is a suitable part to put in, and it looks the same. This one, with the full pack. So yeah, it's called full pack. This is the diode, and you can see if you go in here to the pins, it's like pin 1, pin 3 goes to the center pin. So that's the same part. If you look at the old one, let me see. Go back here. Oh, there it was. So you look at this. See if you can find its data sheet. So you can see here, it's like the one diode going in there, the other diode going in there, pin 1, pin 3. And you can see it's 60 volt, 30 amp. So that's basically how you go about finding these parts you need. Alright, I wanted to thank you for watching, and if you want to see more stuff like this related to cars, computers, electronics, and RVs and things like that, just basically anything random I'm doing, go ahead and hit like and subscribe, and I'll have more videos shortly.